Hey folks, Astronomy here, and I wanted to do a different video today. We have been kind of slacking on videos in the past couple of weeks. I actually do apologize. This project actually has been kind of taking a rather interesting turn. So far, so forth, we have been able to successfully capture at least maybe 4 to 5 transits on this particular object. This object that we're looking at is either an eclipsing binary or it's a potential exoplanet. In this case, we've actually possibly isolated to an eclipsing binary star rather than an exoplanet. And what's really cool is that the detection was made by a group of amateur astronomers, and these amateur astronomers are located worldwide. They're pretty much everywhere. And what I think was really cool is that we had a couple of interesting observations where color cameras were used. And I think that to me is a stepping stone in transit photometry, where instead of the regular method, which we would use monochrome cameras to measure and record transit observations, color cameras were used. And I thought that was really cool. So the way we go about doing exoplanet and eclipsing binary photometry is you would basically take a graph. We would measure the overall brightness change from over time, and over time, if that brightness is dimming periodically, we can assume something is orbiting the star, or it could be something else like stellar rotation, etc. I'm not going to go into too much about that, but one of the ways we would usually go about conducting exoplanet science is like I said, we would actually measure the eclipse depth, and we would be able to get relative information, specifically the duration of the event, the impact parameter, orbital inclination, and the radius of the planet, radius of the star, RP/RS. Basically, that is what those 4 factors usually come to, I guess, unless you got like another method like radial velocity, which I'm not going to go into that method yet because I'm actually still learning a lot about radial velocity. But so with the transit method, there have been over 5,000 to 7,000 candidates so far discovered by tests, but they have not been officially confirmed. Actually, the number is staggeringly low of confirmed candidates versus Kepler. And the reason for that bias is TESS is made to survey 200,000 stars in what's called a sector. So each sector contains about 200,000 stars, so it's covering a field of about 21 pixels per arc second. This satellite has a sensitivity to actually pick up faint super Earths and super Neptunes. And what's also really interesting is that because of the sensitivity of this instrument, it is going to have problems because of its wide field. The optics are also in the red filter as well, and so the red filter, and considering we usually do multispectral color observations to check the depth variations over time to see if they change or if they're not. Usually, if the depths are changing, we actually can assume that this is potentially possibly a false positive. And in that case, if it is a false positive, we can actually either scratch that observation, move on to another one, or we can just work off of what we have on this one, figure out how bad the what's called dilution factor is, and basically figure out if any of the nearby stars are being contaminated, much like Chernobyl. Yes, I had to throw that joke in there. A neat thing when we were going about this paper is that one of the things that was interesting in the observations that were being made is that the filters didn't really seem to be affected. So when I took this to a professional and I showed him the primary and secondary eclipses and so on and so forth, I ended up talking, or possibly we ended up having a conversation. I think it was a one-on-one, and we ended up talking about the possibility of a reflective super Jupiter versus an eclipsing binary, whereas a reflective super Jupiter could theoretically mimic an eclipsing binary, but because of the high albedo of the planet, meaning that it has a reflective atmosphere, the atmosphere is caused by a lot of irradiation coming onto the planet's surface itself. So the planet is being very reflective because of the amount of radiation it's being received. So that's basically what the reflectivity means in a sense. Now, versus the eclipsing binary side, the eclipsing binary is probably most likely the most explanation that we have to date because of the fact that the both primary and secondary eclipses showed peaks in the mid-transit. Now, these peaks are relating to the event of the companion. Now, in observations with M dwarfs, it has been known that M dwarfs are eruptive variables, meaning that they produce violent flares, way more than our own sun will produce in its entire lifetime. So when we went about this observation, we saw a peak in the mid-transit that indicated a potential flare, and it wasn't just an isolated incident. Actually, 4 people caught that observation on the 29th, and to me that was kind of significant because we also had a incident where I think it was on the 15th, or I think it may have been on the 2nd of October, when we went about another set of observations in the past. We saw a similar peak, and that peak, while it wasn't enough to kind of ascertain whether or not we were seeing it in eclipsing binary, it was kind of a distinctive feature that later I'm like, okay, I've seen the same peak before. It was in later data, but it wasn't as confident as before. Now I am certain that we're dealing with an eclipsing binary. And so the next step for the investigation would obviously be to gather radial velocity. Basically, radial velocity is the method in which you would measure the wobble of the star. The wobble of the star actually can be induced by the companion rather than an exoplanet, and in this case, exoplanets can produce small variations in the star's wobble versus a companion can produce large variations of the primary star's wobble. In this chart, you can kind of see how the companion star, or whatever is orbiting the primary star, is actually tugging the primary star, causing a red shift and a blue shift. So when it's a blue shift, it's moving towards you. When it's a red shift, it's moving away from you. This is also known as the Doppler method. So that's one of the things we're going to have to use in the next method, and I think we're going to have to probably contact some proposals or telescope sites to see if they'll actually be able to try to capture it. Another thing that I thought was really interesting about this observation is the timing of the eclipses were just perfect. I've never seen a observation where it was just like in sync with one another. Like everything about the light curve itself, it was just too unnatural. It just felt like it was just like mathematically perfect, if that makes sense. Like everything was following the exact same thing as the orbital period of this companion. And so what that means is that we actually think we're seeing stellar rotation of the primary star following the movement of the orbital period of the companion. That the primary star is locked to the secondary because of how close the companion is and the gravitational and tidal interaction. You're going to get that exact same phase showing every single time. And I thought that was really cool of an observation that the team actually was able to gather. This project has been ongoing for some time, and I honestly think the people that have been making the observations and stuff like that, they really don't get enough credit. I also want to give a shout out to City Astro for, I guess you could say, quote unquote, sponsoring this project that's ongoing, because if it wasn't for him, this group probably would have never been formed, and the data that's been ongoing or is being contributed would have probably never been contributed. And I think that's really awesome that like all these amateurs want to actually contribute to something meaningful with their scopes and you know, their time and stuff like that. And I think that's really cool. I'm just very proud of this project, and I honestly can't thank you guys enough. And you guys actually just have outdone yourself. So until then, I will see you guys later. And I actually think it's about time I head to bed because it's midnight. I didn't realize the time until I checked it. So I hope you guys have a great weekend. Until next time, guys. I appreciate you guys, and stay safe.